Okay, and now for something completely different. I'm going to be talking about secure application deployment and a little bit of SDLC, secure development lifecycle. Make certain that all these things are clicking right. So my name is Tim Mackey, and the last time that any of you saw me speak, I was with Citrix. I was the Zen Server Community Manager. And I am now a technology evangelist, security technology evangelist, outreach program, you name it, with Black Duck. And Black Duck is a company that's been around for about 15 years or so, a couple hundred employees. And this is my third day, so I don't really have all the stats and any of the deeper questions. But for practical purposes, they started out in life as a company that was looking for whether or not open source GPL license was in commercial code. Then it migrated to, hey, there's all these open source licenses out there. Are they compatible? Lawyers love to use the technology during M&A activities. If companies are going public, they like to use the technology as well. A couple years ago, Black Duck went and said, hey, we're sitting on this massive hunk of data that represents the open source of history. We understand what security is about. Let's go and actually start mapping the, shall we say, DNA of what we have today into the vulnerabilities that are existing and start to get a very deep analysis of it. And so a little bit of what I'm going to talk about today is a function of what we've known in the CloudStack world for a little while and a function of what Black Duck's all about. There's a couple call to actions and all that kind of good stuff. And I do have a poster session afterwards, so if you have a deeper set of questions, yes, we'll grab a Sharpie, we'll mark something up, we'll best design win something, take it back to my powers that be to maybe get something implemented. So if we start out and look at security, one of the most important things that we've all come to know is that there is no single solution which is perfect. Defense in depth really truly does matter. I was speaking at Citrix's event last week, and we were talking about some technology that's coming from Bitdefender, where we can now have the hypervisor itself be part of the security posture of a virtual environment. And I'm happy to talk about any of that stuff because it's actually really, really cool. That's not what I'm talking about today, but it's a layer in the overall security puzzle that you have to create. So fundamentally, attacks are really big business. And now you can see the stat that's up on the screen. What you can't see, and I don't know exactly why it's not showing, is that this comes from the Verizon 2016 data breach report. So this is huge business. Data breaches in data center are huge, huge business. And to give an idea of the scale of things, when people are making an attack, they don't necessarily know what they're attacking. They just know that there's some value there. And for me, the best example is the police department one town over from where I live got hit by ransomware last year. They locked the environment down, they locked down all the police files, and I can't remember exactly how much they asked for, but it was something trivial like $250 or $500. It made the news, of course. But if the attackers had known what they were locking, they would be asking for either A, a lot more money, or B, going and saying, sorry guys, I didn't mean to do that. You don't know. These guys are in the business of attacking systems. And so one of the things that we've done to make their life a whole lot easier is open source is truly ubiquitous. The code is up there on a variety of platforms, publicly accessible. The vulnerabilities are published, and a lot of the exploits are published with with guides up on YouTube. And most of these organizations are actually in the business of trying to actively look where people aren't looking closely. So if I take a look at the anatomy of an attack, someone who is going to be attacking a hunk of open source software is going to be looking for probably one of two things. Either an area in the code that has an incredible amount of velocity, where they can potentially sneak something in that is going to pass cursory review. It's going to look like it's solving a legitimate problem, but at the end of the day has some malicious backdoor in it. Or they're going to look at an area of the code where everything looks nice and stable. There haven't been a lot of commits for a while. And in all likelihood, the person who actually wrote that code may no longer be active within the project. That's the area where they're going to try and attack. And so they're going to go and test against all these various deployments and platforms. They'll take some of the best practices guides and say, well, everybody's deploying it this way because, gee whiz, that's what we said we wanted to do. And they'll iterate over it. First attack fails, iterate, 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 until all of a sudden you've got something that works. That's when you go and you create your deployment, and you go and you build your toolkit that somebody out there will go and want to use. Now, the somebody is, well, various malicious actors who don't actually have a software engineering department and a QA department to perform all this work, and they look to places like YouTube to go and discover what they've got. And that's how things worked until recently. Then we started to get into the lovely marketing names for vulnerabilities like Heartbleed and Shell Shock and Venom. So we added another step. Don't forget the PR department, because today it's all about being able to promote your brand and the capabilities of what you have. So if you're going to be attacking something, you want to be known as a good attacker. If you're a security researcher and you're discovering this, you want to be known as a fantastic security research company. And so it's kind of a double-edged sword out there, and it's all following this particular model. Now, if we look at some of the more basic projects out there, like just take OpenSSL in terms of an independent project, we can see that there's a ton of different variants that exist. The problem is some of this code is actually baked into things that don't necessarily on the surface look like they have OpenSSL. If we look at new people looking at a piece of technology or new developers to a project, they're going to try and solve problems in interesting ways, and they're going to look to the internet for, how do I solve this? Here's a hunk of code. It solves my problem. It passes my unit test, but it doesn't necessarily pass a security test, and how do I actually validate that? So you have code that can come into a project from a variety of different ways, all becoming lovely commingled code, and this is what ultimately gets delivered. So using OpenSSL as an example, and then using Zen Server as kind of a backdrop to this, there were a number of OpenSSL vulnerabilities that have occurred or been published over the last couple of years, and inevitably someone on Citrix's internal list would go and say, hey, here's a CVEX, is this something that impacts Zen Server? And sometimes somebody would say no because the version doesn't match, not realizing that maybe internally Citrix had forked that version but not necessarily bumped the version number. Now, I'm not saying that that ever happened within Citrix, but that's a perfect example of why just looking at something as simple as a version number isn't necessarily going to give you what you're looking for. So from a security responsibility perspective, there fundamentally are two different models. The first is the commercial software model. Oracle, for example, will go and give you a nice quarterly list of updates. Microsoft has its Patch Tuesday. In both situations, it's the commercial vendor who's ultimately responsible for the security of the thing that's being delivered, and it's who their users are going to look to for some measure of governance and guidance around how to deploy things in a truly secure manner. The flip side is on the open source, where if we have a random project, any random project, the security maturity cycle within that project varies widely. Perfect example is last year there were a series of vulnerabilities that were reported within QEMU, and the Zen project, which consumed QEMU, had a very mature security response policy. You had to A, be a recognized organization, B, have a fully defined security response policy of your own, C, be subscribed to the Zen project's security response lists, and D, have some measure in which you were a large enough organization for this to not be noise, because the last thing any security segment wants is a lot of noise. Flip side was QEMU. And while internally Red Hat had a number of patches for things that were part of this particular set of vulnerabilities, it turned out that the QEMU capabilities for just the pure open source side of things were a lot less mature. and things were not getting done in a more timely fashion. And so that introduced risk. And the last thing that we want as a open source supporters is for somebody to go and stomp their feet and say, gee whiz, but closed source and commercial software is the right path because they're doing things in a more complete fashion. Open source has got a lot of value, and we don't want to be in that boat where we're taking a couple steps back. So from a Black Duck perspective, we looked at how the packages are actually maintained. So if we go and take a look at all of the package managers out there and package creation tools, they all create a set of dependencies, and let's assume for the sake of argument that they're all actually completely correct and complete, which is arguable, but they all represent what the, lovely, in advance, let's go back. They all represent what the developer expected to be there, not what is actually deployed. So the moment that you go and patch something, SSH, OpenSSL, what have you, you've now deviated from the expectations of that package. So what Black Duck actually does is a whole lot of hashing fingerprint work to go and create manifests of stuff that's there and build hierarchies and so forth to represent what you actually have on a system as opposed to what is part of the actual package manager's view of the world. This is a representation of the current, as of 2015, number of vulnerabilities that are publicly available and those that aren't. Now I've circled the it's not. A lot of people go and they take a look at the CVEs that are published in the, I'm loving this auto advance. Take a look at the CVEs which are published in the National Vulnerability Databases and say, aha, this is what I need to do. The problem is that the majority of those things are actually written for humans, not machines. So you don't necessarily know exactly what you've got. And then a trend has started to emerge where not everything that is disclosed is actually published. Or worse still, not everything that is disclosed is published in a form that you can accept. And as it turns out, Zen is a perfect example of this. So when Zen goes and creates what is called an XSA, a Zen Security Advisory, we go and we define one, we give it a number, we go and create a corresponding entry in the CVE. But if you go and take a look at, for example, XSA 106, which was one that Amazon had, which required the majority of Amazon's environment to be rebooted, the CVE that corresponded to it said a security advisory has been reported. And that was it. That's all it said. And in the XSA, you had to then go and dig into the list to go and figure out what it was. So if you're administering an environment, there's a lot of work that needs to go into that. And one of the things that Black Duck's got as part of its sweet spot is being able to go and unravel all of that so that you, as operators, have an opportunity to know exactly what is going on when. So the next obvious thing, and I've been a developer for a very, very long time, is what about analysis tools? So static analysis tools have been around for ages, dynamic analysis tools and fuzzers have been around forever. If I look at all of the things that are out there, and I look at the various tools that are available to me, I'm going to cover a subset of what's there. The problem is that a lot of the undiscovered vulnerabilities, they're really too complex to actually be detected by these tools. And I didn't have enough brain power to remember exactly what the name of the vulnerability was, but there was a vulnerability that was discovered in the Linux kernel a couple years ago. And this is how nuanced the world would be. So someone had submitted a patch that was going to improve the network stack and when the network was a little less reliable than what we have come to expect from networks today. And in order to perform that optimization, they took a look at the packet. The packet came in as a structure and they dereferenced an item on that structure. And if you're C developers, this is all perfectly natural things that you would do. The next line after they dereferenced this value was if struct not null, or if struct equals null, go off and do this error reporting, save us from bad things happening test. The problem was that GCC, in its default setting, went and said, aha, you've got this lovely structure that you've dereferenced. You are telling me, by virtue of dereferencing it at this point in time, that you know that this will never be null, and immediately optimized out that test, which meant that as soon as that pointer became null, you now had your classic buffer overrun. The security, the static analysis tools, the dynamic analysis tools, they couldn't find this because from their point of view, the test was being done correctly. The best they could do is flag that here's a null pointer dereference potential problem, and it was in noise amongst everything else. So being able to know patterns of behavior becomes really, really important. And lovely stat of there are over 3,000 vulnerabilities disclosed in 2014, and less than 1% of them were found by the various analysis tools that are out there. So I love audience interactivity. What unique things do these all have? And please don't say marketing names. Paul. What was that? So all of these are things that have been there for a very, very long time. All of these are things that are ubiquitous in our environments. Everyone has Bash. Everyone has OpenSSL. Some of these things, the developers are long since gone. If you remember the shell shock discussion, it was how are we going to fix this? The behavior is actually ingrained in a lot of our assumptions. These are the types of things that people are going after, and these are the types of things where you don't necessarily know that you've got the vulnerability because you're basing your environment off of what's being built, not the application itself. So if we think about our system templates, we go and we bundle this lovely VM image, and into that VM image we have Bash, and we have OpenSSL. And we all know today that OpenSSL has a ton of vulnerabilities in it. What if we accidentally put an OpenSSL version that has a vulnerability that's discovered in 10 minutes? How do we solve this type of problem? And so this is one of the things where I want to actually have this as more of a discussion, and why I proposed a poster session, is that from my perspective in the CloudStack world, there are a couple of opportunities that we have. The first is in our own code that we're generating, being able to go and perform the analysis as part of our CI and CD capabilities. But to also look at it from the system template perspective, so that we know exactly what we've got in the templates that people are going to be deploying, such that when someone goes and says, aha, that this is CVE of X, we know based off of the manifests that have been created, the evidence that's been created, what we have available to us and what we should be looking at. The second opportunity is in template management itself. So if we have user templates, and those user templates are being uploaded by somebody, how secure are those user templates in our clouds? What does it actually mean to be deploying a secure environment? And follow on to number two is in terms of whatever we're doing with user data. The things that people are putting in. Can we bake in an aspect of this into the actual template management, template deployment lifecycle, such that CloudStack itself is inherently able to deliver a more secure experience for the cloud consumer? If I look at some of the investment that has happened, the one thing that we can say is that firewalls are big business. Everybody wants to invest in the latest set of scanning capabilities in the firewall. However, the reality is people are not attacking firewalls. The perimeter is just where things are. What we should be investing in is ways that we can improve the application security such that we can divert that energy away from the firewall into the application layer and have a more secure environment. So I'm going to skip this slide, and I'm going to go right to this one because Will's given me the 5 minutes. I said at the beginning that it's a defense in depth. Last week I was talking at Citrix Synergy around how we could do rootkit mitigation at the hypervisor layer with no agents inside the VMs, which is really, really cool stuff. That's part of the puzzle. The network security layer is also part of the puzzle. Knowledge is power in this. Knowing what's running in an environment, knowing how it's built, knowing why things are the way they are, that's huge. Defense in depth is really truly the only way that we're going to be able to solve a lot of these types of problems, because at the end of the day it is a little bit of an arms race. There's an entire industry that exists around creating malware and attacks, and our little widely deployed project, we're not equipped for as much of this as we might want. And if we're in a position where something like a black duck model can be valuable, I think it's valuable to have that kind of conversation and embed everything into the entire development and deployment process for all the customers. So my big theme this year has been together we can build a more secure data center. I see this as part of the puzzle, and this is one of the reasons why I left Citrix to go and join Black Duck. It's cool stuff. Thanks.
Do we have any questions for Tim?
Mike, don't run away.
I just want to see you from this side of the room. Perfect.
No post in the way? Whiteboard.
Anybody? I'm not getting any questions on Slack.
I put everybody to sleep. My mission here is done.